Today I'm going over the ideal gas law, the combined gas law, and all the other gas laws just are in the mix when we're figuring out what we need to use. So looking at this, we have volume, atmosphere, and temperature, trying to figure out the new volume of a weather balloon when it ascends. So the whole question is, a weather balloon contains 233 liters of helium at 22 degrees Celsius and 760 millimeters mercury. It ascends to an altitude where the temp is 54 degrees Celsius, 511 atmospheric pressure. What is the new volume? So whenever we're dealing with gases and stuff like that, we have to really know the different gas laws. So Boyle, Charles, combine, Avogadro, Dalton, the ideal gas law. So yeah, knowing that we're dealing with temperature, there's only a certain number of things that we can do, and we have not only volume, but we have temperature and pressure. Not only temperature, but pressure as well. So that rules out Charles. So now we're doing the combined gas law, P1 V1 over T1 equals P2 V2 over T2. So in order to get V2 by itself, we have to multiply the reciprocal, which is T2 over P2 on both sides. And this is what we get. So now, going back up to the question, we're ready to plug in the numbers. So P1 V1 T1 is all the initial numbers that we have at when the balloon is at 760 millimeters per mercury. So we're going to start with T2, which is the second temperature, 54 degrees Celsius, times P1, pressure 1, which is 760, and our volume 1 is 233. Liters. Okay, this is all over. P2, which is 511. Because the pressure reduces when we go higher, there's less gas pressing down on us. So that number is going to go lower. And T1 is 22 degrees Celsius. Rightio. Now that we have all that, we can plug in some numbers. So whenever we're dealing with any of the gas laws, we have to convert to and this is minus 54, I'm sorry. Woof. So minus 54 plus 273 is going to convert it to Kelvin for us. So now we have 219 Kelvin. Down here, 22 degrees Celsius plus 274 is 296 Kelvin. Plugging it in, we have 219 times 760 times 233. Got a big old ugly number. Three 8780520 over 511 times 296. Now we divide. For volume 2, equaling 256. We'll figure out what our sig figs are in just a second. So we started off with, we have 3 sig figs. 1, 2, 3. So we have V2 is equal to 256 liters. And over here, I don't have 256, but it's probably because I didn't put in the decimals having to do with Kelvin. But I know we're close enough. 256.